Hey guys, welcome to today's lesson. We're going to go over displacement versus distance. Split your screen so you can see your student notes and click on any links that you need, and you can also type on those. So click on the tab for displacement. In this section, you're going to differentiate between distance and displacement. First off, what is motion? If something is in motion, it's considered to be moving against some background that is stationary. Take a look at the diagram below. Here we have a coordinate system, which is the number line, and the 0 mark is considered the origin. This large tree here is at some position to the right of the origin. We could say it's about 4 meters from the origin or 4 meters to the right of the origin. So in physics, we use a coordinate system to analyze the motion of an object. You're going to be giving directions to indicate where the object is from the origin, and these directions can be given as east, west, north, or south, as angles, as a relative position from any fixed point. You'll also denote a positive direction and a negative direction because physics includes math. A positive and negative value in your equations is very important. So to distinguish between distance and displacement, now in everyday language, you might say I walked some distance to class, but the term displacement is a little bit different. You might say I walked 100 meters from my car to class, and that would be a displacement if you also include direction. So basically, displacement is going to be distance and direction. With that said, can you have a negative position? This tree here is about 4 meters to the right of the origin, but this green arrow is showing something going to the left. We could say that a cat walked 5 meters to the left. And in this case, the coordinate system shows that left is going to be negative and right is going to be positive. So yes, you can have a negative position as long as you indicate that on your coordinate system. In physics, we use symbols to organize information, whether those are letters to represent variables or arrows called vectors to indicate a magnitude and a direction. So the arrow in the previous diagram we said indicated a cat walking to the left of the origin. That told us how far the cat traveled and also in what direction. So that would be a vector quantity. Vector quantity includes both magnitude and direction. Displacement is a vector quantity because it includes direction. Distance is considered a scalar quantity. Scalar quantities do not include direction. So examples of examples of vectors include displacement, velocity, acceleration, and force. All of these will have a direction included with the value, which is the magnitude of the number. Scalar quantities, for example, are speed, time, temperature, mass, and distance. I put a picture of my fish here because he has scales. Isn't he cute? He's about twice that size now to scale with my computer screen. But anyway, scales. Fish have scales. Get it? Scalar quantity. Haha. Let's see if you understand the difference between distance and displacement. In your science notebook, go ahead and label this class examples, distance versus displacement. Number 1, a chicken walks 5 meters to the right of a tree. 1, 2, 3, 4, 5. He stops to peck at an insect, then continues walking in the same direction for an additional 4.5 meters. What distance did the chicken cover? What do you think? Yes, obviously that is 9.5 meters. Good. What was the chicken's displacement? Now, what did we say is the difference between distance and displacement? Displacement has one extra thing associated with it. What is that? Direction. So the chicken's displacement would be 9.5 meters to the right of the tree. And that's all there is to it. Number 2, a golfer puts a ball that rolls 5 meters up an incline and then back down 4.5 meters and comes to rest on the ledge. What distance did the ball cover? So distance is a scalar quantity. It's simply additive. So 5 meters plus the 4.5 meters it rolled backwards gives you 9.5 meters. Good. Okay, what was the ball's displacement? So again, displacement, the distance from the origin, go 5 meters up, 4.5 meters down, comes to rest on a ledge. What is the ball's displacement? Well, from the origin, or from start to finish, it is 0.5 meters. So 0.5 meters from the origin. When you walk from class to class in school, you cover a great distance. However, get this, if your last class is in the same room as your first class, then your displacement for the day is 0 because you're ending up in the same place that you started. So you are no farther from the origin than you started. Distance is total length, whereas displacement is a change in the object's position, and position is a point. Now, to represent position, we use the symbol D for displacement. Sometimes you'll see it indicated as an X horizontally or as a Y vertically for the change in position. Now, the change itself is displacement. We write this as final displacement, dF, minus initial displacement, di, equals a change in displacement, delta d. So delta, this triangle, Greek symbol, delta, means change. That means you subtract final minus initial, whatever it is. Checkpoint. Can displacement have a negative value? Yes or no? Yes. It has a magnitude and a direction. Can distance have a negative value? No. Scalar quantities do not have negative values associated with them. And distance is scalar. Can position have a negative value? Yes. Okay, let's see if you understand what vectors are. So a vector is a symbol, it's an arrow that represents the magnitude of a value and its direction. So first we have a vector that is 5 meters in length and another vector that is 4.5 meters in length. When you add these together, what do you get? 9.5 meters is correct. Did you also say to the right? So this is 9.5 meters to the right, if you were to write this in words. The first vector is 5 meters plus the second vector, which is 4.5 meters. To the left, what is the resultant vector? Okay, notice the first one's going to the right, the second one goes to the left. So 5 meters minus 4.5 meters, it gives us 0.5 meters to the right. This is the resultant vector. The resultant vector is the vector that results from start to finish. So if I were to overlap this vector with this one, this would be my starting point, this would be my end point for an object that traveled 5 meters to the right and 4.5 meters to the left. So the final displacement is 0.5 meters to the right of the origin. Number 3, I'm not going to give you values for this one. Let's just see if you understand the direction of the resultant. So we have vector that is going up and to the right, one that is going straight up and it is longer, one that is going directly to the right, and one that is going straight down. When you add vectors, you add them tip to tail. So it does not matter what sequence you put these in, you're always going to end up with the same resultant. Drawing them tip to tail without rotating them, imagine you pick this up and you move it tip to tail with the first vector that I've drawn here. Pick up the next one, pick up the next one. The resultant vector is drawn from start to finish. Later, we'll get into measuring the exact angle as measured from one axis. Again, it does not matter which sequence you put your vectors in, the resultant is the same. Let's try a few more. Try these on your own first and then come back and check your work. So pause this video, pause it now. Welcome back. For the first one, did you get 8 kilometers to the right? Pick this one up, move it tip to tail with the first one without rotating it, and you get a total of 8 kilometers. For the second one, you have 3 centimeters to the right and 5 centimeters to the left. Your resultant from start to finish should be 2 centimeters to the left. And lastly, if I were to pick up this second vector and put it tip to tail with the first one, you get 4 centimeters up. Your resultant should be 5 centimeters in this direction. You don't have to draw that to scale, but there we go. I want you to click on this link. It's going to take you to a PhET simulation. Explore this simulation. Grab a vector, put its tail on the origin. Grab a second vector, put its tail to the tip of the first one. You can add as many as you like, adjust them to any length, and check out how the resultant is additive. So when your vectors add together, you end up with a resultant. Put 4 vectors on there to start with. Click any options at the right on the sim to play in the sim, and see if you can make your vector sum equal 0 by rearranging multiple vectors. All right, go explore. Come on back when you're done. Welcome back. You're going to check either your student notes or on Schoology for the problems that you're going to do in this problem set. If you have any questions, send me a message.